Here's the video I told you I'd make that'll show you how to take the data from your graph and let Excel do all the heavy lifting for you to figure out what your slope is. I want you to know that. You need to be able to do it manually, but I'm also, at least in this case, more interested about you getting, hopefully, the right answer. I'm using Office 2007. If you're using 2007 or 2010, it should look roughly like this. Prior versions, 2003, which was also called XP, and there was one came out in, I think, 2000 maybe. If you're using one of those two, this will look a little different, and I don't even have a copy of one of those older ones hanging about that I could make a video specifically for you guys. So hopefully that'll be minimal. You should be able to get from what I say to what you need to do if you have one of those old versions. First thing you need to do is enter some data. I'm going to go ahead and give it a name just to keep it straight, and Excel actually is able to use that name and understand what it's all about. So recall that on the data I entered the columns backwards. I put column Y first. We're going to fix that. On column X we want how much it stretched, delta X. So I'm just going to, in this cell, I'm going to type delta X. There's a way to get the actual delta sign in there, but I don't want you to have to worry about that. I can teach you that if you want to know, not what we're doing in this lesson. And then on the y-axis was the force we were exerting on it, because we're really trying to derive that formula that we all know kind of now. Force is equal to negative S times delta X. Now, I just need to enter my data in here, and I'm going to pause the tape while I type this in just so you don't have to be bored by it, but this is what it looks like. There it is. Wasn't that magical? Notice that I converted this to meters, and this one is in newtons. Hopefully you did all that with your data. Now, I'm about to tell it to make a chart. All I got to do is click anywhere inside my data. If I click over here and tell Excel to make a chart, it says a chart of what? So click in here, and when I say make a chart, it's going to say, oh, make a chart of these numbers. So up at the top, insert, and then in this section right here, there's a great heaping pile of charts you can make. We want what's called a scatter graph, and I'm going to use this little down arrow to tell it I don't want anything with lines, I just want my data points. So I click that, and the next thing you know, there is my data. Easier than doing it on graph paper, isn't it? Now, my data looks fairly good. I got a couple of weird points here. There's one that's out, and this one's a little out. I'm going to blow that up, and the way you do that, just click in the graph anywhere other than, on one of the little sides there. Then a right click, not that. A right click will give me the choices where I'm going to move my chart, and I'm going to move it to its own sheet. Now, yours probably will say chart 1. If it says something else, that's fine. Whatever it says, that'll be the name it gives to the sheet. So when I click OK, it moves it off of here and moves it to its own sheet. If you look down here in the bottom left, I now have something called chart 1, and over here, sheet 1, is where all that data was. Okay, let's go back to chart 1 and look at it. Now, yeah, that data looks okay. The bigger it is, the more you can tell I obviously did something wrong there, and that's a little high, and that one looks a little low to me. But Excel doesn't care. Excel will use my data. If I click on any of my data points, it will highlight all of them. And then I'm going to right-click, and the choice I want to look at is add a trend line. A trend line is really make your line of best fit. Now there's a number of choices here. Excel, as soon as I click that, Excel looks at my data and says, I think that's linear. So it chooses linear for me, but there are some other choices either it could make if my data looked different, or even if my data wasn't very clean, and I said, oh, this is a polynomial, I could force it to that. In our case, linear is what we want. You don't have to worry about any of this stuff in the middle for now. Down here at the bottom, there are 3 things that you need to check all 3 of them, and here's why. I'm going to check set the intercept to 0, 0. I know that if there is no weight hanging on the spring, then there is no delta X. That is, it doesn't stretch out the spring any. So I'm just telling it, when you graph it, know that 0, 0 is one of our data points. And then I'm going to click display equation on chart, that is going to tell me useful things like what my slope is. And then display R squared value. Later when you take statistics, you will understand more what your R squared value is. But essentially it is how close to a straight line is my data. The closer that number is to 1, the cleaner my data is, the more it conforms to what we think it should conform to. All right, so I'm going to click close to get rid of that. And then I'm going to take this. You don't have to do this part, but I'm going to move it and make it just a little bigger so that I can read a little more efficiently. That. There. All right, my R squared value is 98%, so that's pretty good, even though to look at it, I'm not so overjoyed with that. Excel did the math and says, hey, you did a good job on your lab. Thank you, Excel. Now, this right here, that's what you really want to know. This y is equal to 41.03x. For us, the y-axis is force. The x-axis is delta x. So this is that force formula. Y is equal to some constant, S, the spring constant, times delta x. Now the negative is not in here because we entered both of our data as positive numbers. That is, even though the forces were pointing upward and they're positive, if I had made these negative numbers, then that negative would have been in there. But I think we all know how to work around that, so that's not a problem. So Excel tells me that the slope of my line is 41.03. I know what this data I got from a student, and I know what spring they had, and the correct answer for their spring is 40 newtons per meter is the value of their spring constant. So 41 is pretty good. I'm going to take a calculator and figure out what my error percentage is here. You'll remember the way we calculate errors is it's the correct answer minus what you got, the absolute value of that, divided by the correct answer. So I'm going to take 40 minus 41.03, and of course that's a negative number, but take the absolute value, and then I'm going to divide it by 40, the correct answer, and then I take that times 100, which gives me a percentage, and my error percentage on this is 2.6%. Very, very good. Anything under 10% is wonderful. Anything under 15 or maybe even 20% is certainly acceptable. So that's that one. Now, what about the other data? Well, I'm going to go back to my sheet, and I'm going to leave a column blank here. If I start another column over here, Excel will know that data has nothing to do with the former data. So the information on the back of the lab, it would be in the first column, we had mass. I couldn't remember what we had. We had mass. And in the second column, we had period. And again, I'm going to pause this and type my data in, so stand by. There we go. This student took a few more data points for the period. That's no big deal. But again, all I got to do is click in it and say insert a scatter graph, the one that just has dots. And there it is. Oh, that's pretty. Look, it was supposed to curve, and dang, it curved. Let's do the same thing. Let's make it bigger, move chart. Now it has a different name here. Again, yours may be, mine says chart 2. It may be something different than that. And you can give it its own name if you want. I could call it the curvy graph. I could even misspell curvy. Or, excuse me, misspell graph. Down here, the curvy graph. All right, now that really, I mean, it really shows me what I want it to show me. It looks really straight up here, but then as I get close to 0, it makes a nice curve. Now, this student did a really good job of getting a bunch of readings with not much mass on it. There's 20 grams and 50 grams and 100 grams. So, yeah, they did 150. They took a lot of data down there, which makes it even more curvy. But the only reason we do that is so that we can say, oh, I recognize that graph. That's a square root graph. Now, let me go back and graph what I really want to do. So I'm going to make a third set of data. This one I'll call square root of mass is my first column. My second column is going to be period. Now, at this point, you can do one of two things. If you've already done that math, you've already taken your square root of all these mass points, you can just type them in here. I'm going to actually show you how to do put a formula in here. It's really not that hard. So to tell Excel that you're about to give it a formula, you have to hit the equal key. And as soon as you do, it says, aha, this guy's going to tell me something, going to give me some information that will allow me to process data. So I want to take the square root of the mass that is located over here. So there's a whole lot of kind of built-in formulas. I happen to know this SQRT is how it abbreviates mass. Type that in and an open parenthesis. And now I just have to tell it what number I want it to take the square root of. I don't have to type 0.02 in there. I can just go click in it and it says OK. Now I'm going to put a closing parentheses in. I'm going to hit enter. That takes me out of the mode where it says I'm building a formula. And now let me go back up here and look right up here, this area that I've just highlighted. That says this cell G2, should take the value in D2, which is column D, row 2, this 0.02, the value there, and take the square root of it. If you want to verify that, you can get your calculator, take the square root of 0.02. I think you will find it will be that. Now, the good news is that Excel's really smart. I could type that same formula here, and here, and here, but Excel does all the heavy lifting for me. I click back in this cell. I'm going to right-click and copy. And then, this is not how I would do it because I'm going to add an extra step, but just to show you, click down there, right-click and paste. And then look up here. It said take the square root not of D2, but of D3. So it knew what I wanted. I mean, I actually told it what I wanted, but it was able to figure that out. So really what I could have done, I'm going to delete this. What I could have done is say, click here and then right click to copy. And then said, I want you to copy that to this entire row. Paste. Oh, it's a beautiful thing. Now, that's kind of ugly in spite of the beauty because it's got all these zeros out, or all these numbers out here. I'm going to do one thing, not strictly necessary, but Excel is a very powerful piece of software. I highlighted all my data. I'm going to right-click. The contextual menu, one of the choices is Format Cells. And I'm going to say, this says keep all that data, but only show me 2 decimals of it. Oh, we'll make it 3 decimals of it. Oh, that's a whole lot cleaner. Now, for period, I could hit equal to say it's going to be a formula, and then just click here. If I hit entered, it copies it right over. And then I could do it for the entire deal, well, the entire column, but I'm going to do it a slightly different way. All I really have to do is highlight this, right-click, copy, and then click in the very top cell, right-click, paste. So now I have data that is square root of my mass and period. I'm going to click in it. I'm going to do the same thing I did. Insert one of them there scatter graphs with just the dots showing. Looks linear to me. Right click in it, move it to not so curvy now. Suddenly I'm Canadian. Oh, he didn't like the question mark. Okay. Excel can be a bit of a smart aleck at times too. All right, that's my data. I'm going to, like I did before, click on one data point, right click, add a trend line. This one is linear and it knew that. I'm going to say force it through 0, display the equation, and tell me how clean my data is. And again, you don't have to do this, but so you can see it on the screen pretty easily. Okay, first off, my R-squared data, the closer this is to 1, you'll recall, the better my data is. Wow, that's beautiful. This actually will probably be a little better than your data. Your data will probably be in the 0.96, 0.97 range, something like that, which is good. Now, here is my formula. The slope of this line is very close to 1.9919. Recall what this is. On the x-axis, I have the square root of the mass. On the y-axis, I have t, the period. So you will recall, probably from the thing we did with pendulums, that the slope of this, and if you look at the formula for the period of a pendulum, you should get this. The slope of that line, t equals something times the square root of mass. The something, the slope, should be 2 times pi divided by the square root of s. Well, I can't show you this on the screen real easy, but I'm going to take my accepted value for s, and 2 times pi divided by the square root of my accepted value for s is 0.9935. And this told me it was 0.9919. That's very good. As a percentage, I'm less than 1% off. That actually is surprisingly good, almost unbelievably surprisingly good. Nonetheless, now, here's what you ought to do. Take this. You can, by the way, if you want to change any of this, you just click here, and there's all kind of great ways to make this pretty and do all kind of cool things, which you're welcome to do all that if you want. Print this off. Print this off. Print this off, all three of those graphs. And now all you have left is for me to tell you what the acceptable answer is, that is the correct answer for S for your spring. And do 3 quick calculations, and you'll be done with this lab and get 100 on it. Ain't life grand. Okay, hopefully that was enough to get you going. If you have any questions, well, you know my email.